Okay, let's go ahead and we're going to look at the last section of the chapter, and we're going to talk about box plots to help us to display our summary from skewed data. First thing I want to talk about this picture is this is San Francisco. There's the Transamerica building way back there. This picture was taken standing in Alamo Square Park, and these houses are called the Painted Ladies or the Seven Sisters. The contractor was an Irishman who lived in this first house farthest down the hill, and he built these other 6 as spec homes. And these were built, these were not destroyed in the 1906 earthquake in San Francisco. The fire line was about a mile behind them where the city burned down, and they burned blocks of the city to stop the fire from spreading. But I just want to tell you that this house on the bottom of the hill was used in the movie Twins. I toured this house. This house has its own agent and is used in a lot of movies. This yellow house is the house that they use for the exteriors in Full House. So that's your TV trivia for today. Okay, let's go on to 3.5. And what we're going to do is we're going to talk about outliers. And outliers are extreme data. And what happens is we find the fences. And what constitutes an outlier is if it lies beyond 1.5 interquartile ranges from quartile 1 and quartile 3. So the lower fence, we take that value and subtract 1.5 times IQR. The upper fence, we take 1.5 times the IQR and add that. When values are beyond these, they are officially outliers. If they don't meet that criterion, they're just extreme data values. They're not technically outliers. So here we go. If earlier in the book they talked about the high temperatures in San Francisco, the first quartile is 59 degrees and the third quartile is 70. Using these values, what would be considered as an outlier? Well, our IQR so we're going to find the IQR by taking 70 minus 59. We're going to take that times 1.5 and subtract that from 59 to get 42.5 is our lower fence. We're going to take that difference times 1.5, add it to 70, and 86.5 is our upper fence. Now, I was in San Francisco this summer, and I think it was 100 degrees, so I'd say that was an outlier. Official outliers are below 42.5 and above 86.5 degrees Fahrenheit. Now, that brings us to a box plot, and a box plot is the plot we use to summarize a skewed data where we use minimum, maximum, median, quartile 1, quartile 3. Those 5 numbers are called a 5-number summary. Let me say that again, but let me say it in order. Minimum, quartile 1, median, quartile 3, maximum. Those are the 5 numbers in a 5-number summary. The thing that we need to remember is that box plots are good for unimodal distributions. They will hide any multimodal information. And the other thing about box plots is we do not use them with small data sets. Box plots should not be used for very small data sets, and they should only be used for unimodal distributions. And the other thing box plots are great for is they really help us compare distributions. So here's an example of a box plot, and these are the daily high temperatures in San Francisco. And we know our minimum was 49 and our maximum, we had our lower fence and we had our upper fence. Our upper fence was here at 86.5. We had 1, 2, 3, 4, 5 outliers in this data set that were beyond our upper fence. So the minimum value is 49, the median value is 64, and we have 5 potential outliers. So let's take that weight data that we've been working with and let's draw a box plot. So if you go back to the slides that had that data on it, we know quartile 1 was at 127. And we know quartile 3 was at, oh man, I forgot what it was, but it's about 196. And then we have we draw a box. That's what's called a box plot. And then we put our median in that. Okay, and our median was at 175, I believe, 174. Now what we do is we put the whiskers on the box plot. Sometimes these are called box and whisker plots. So we put our minimum that was 100 and we put a little tick there, and then we draw a line. We take our maximum, which was like about 280, and we draw a tick there, and then we put a line. So there is our box and whisker plot for that weight data. So that's how you go through and do your box and whisker plot. Now, on the calculator, this is how we do it. So here are the directions. I'm going to pull up my TI-84. Let me turn it on. And I have the gas data, and I used all 12 data points that are in your textbook rather than the 10 that are on the previous slides. So this is my gas data, and let's just quickly go to summary statistics, stat calc, one variable statistics, and you can see that my minimum is 293, quartile 1 is 296, median is 299, quartile 3 is 309, and my maximum is 319. Okay? But let's go through. So we have the stuff in our list. So we're here at step 3. I'm going to do second and then y equals for my stat plot, and I'm going to hit enter twice. It's already on because I've already done this, but I would click it one more time, and then I use my arrow keys here. Oh dear. Use your arrow keys to get to the box plot that looks like it has outliers, so with the little dots. Okay, and I'm going to push enter. Make sure my list is at L1, frequency is 1, and I'm going to use little squares. Oh, so then I click graph. There's my graph, and I'm going to hit zoom 9. And that's so I can see it all, and you can see it right here. Now what you want to do is you want to do trace, and you can see there's my minimum at 293. I'm going to use my arrow keys. There's my quartile 1, there's my median, there's my quartile 3, and there's my maximum at 319. Now this one has no outliers, but some things you can see here. Remember, this box has the middle 50% of the data, and the box and my whisker are very much longer here on the right side than they are on the left. This tells me that the data was skewed to the right. Okay? Now, that's how you do a box plot. The directions are there. Very nice. What I'm going to do now is I want to pull up StatCrunch. So let me drag StatCrunch over. And this is the same gas data. The first thing I'm going to do is let's go ahead and let's do a graph. And a dot plot's good, just to get an idea of the shape. And you can see it's kind of skewed. We can do our stat, summary statistics, columns, variable 1. Let's go ahead and let's add interquartile range in there. When you don't want the sum in there, you use Control and click, and you just get interquartile range. And there is my median, my minimum, my maximum, quartile 1, quartile 3, and interquartile range. Now, I will tell you, don't get upset when your quartile 1 and quartile 3s don't match exactly. Different technology uses different rules. We leave the median out. Some algorithms don't, but you'll be close enough. All right? But what we want to do is let's go back to graph, and we want to do a box plot and variable 1, and I can put the mean in there. We know that mean is 301, and we expect the mean to be bigger than the median. We'll just do that. We're going to compute, and there we go. So notice our median is at 299 and our mean is at 301. That's another hint that it is a skewed distribution. Some other things about StatCrunch is you can draw your box horizontally if you want to. So there it is. And if you put your two data sets in the same spreadsheet, you can put two box plots either side by side or one on the top and one on the bottom. Okay? So that's kind of what happens there. So let's look at comparing two distributions. We've got San Francisco and Provo, Utah. Note that they say both distributions are roughly symmetric. And we see what the mean is in Provo and in San Francisco. But their spread is very different. And here we go. We have the box plots side by side. Notice that San Francisco, the median in this case, is a little below Provo. Notice that the Provo data is more spread out and has no outliers, where we've got some outliers in our San Francisco data. And so how do we know that Provo is more spread out? Well, first of all, our box is wider, and second, our whiskers are also wider. So if we have a 100-degree day in San Francisco, that's unusual. If we have a 100-degree day in Provo, it's not, because it's simply in the upper 25% of the temperature of days of temperature. Okay? So as we look at this, we consider our 5-number summary. And our 5-number summary is minimum, quartile 1, median, quartile 3, and maximum. And notice that in this case, our maximum is above our upper fence. So now if we go back to our case study, we talk about how do people perceive risk. And so they had 500 subjects rate activities on the risks involved. And we're going to look at the risk of appliances and the risk of x-rays. and they want to look at the differences among men and women's perceptions. So the distributions for men and women are similar. They're both right skewed. So guess what? We should use the median and the interquartile range. And here are some active learning questions to help you review what we've talked about. I'm not going to speak on these slides, so I'm just going to do the slide for 3 seconds, and then I'll do the answer for 3 seconds. If you need to pause the video to better understand the question before you look at the answer, that's wonderful. If you need to speed up this part of the video, if you watch it in YouTube, you can do that.